Hello everyone. So today I have one more problem on data structure array. So this is called move zeros. It's very easy problem, but again, sometimes easiest problem they also done in very I would say not very good optimized way. So I'll see this is a very easy problem. That's why the interviewer is expecting you to give the most efficient solution, which definitely involves a little bit of trick. You can see here, note that you must do this in place without making a copy of the array. So brute force approach is, of course, from the very beginning is it is kind of not allowed to use. So, but still, let's read the problem. So, given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. For example, 0, 1, 0, 3, 12 is the array. So you see 1, 3, 12, they should be in the same order. You see 1, 3, 12, but 0, 0, they are moved to the end. So that is pretty straightforward, simple problem. So let me quickly code this problem in IntelliJ, and then we will see how it works when it comes to the approach. So move zeros. There we go. I copy this solution description. I mean problem description. I copy this and paste it here. Cool. And now I write my main method. It will be my logic. Then, sorry, it will be my input. Then logic. And then output. All right. So what is my input? Input is my, again, array, which is here I can copy all. And then, yeah, so that's pretty much all. We have an array. And then logic is where we need to write some method, because it's already it's saying that you must do it in place without making a copy of the array, right? So you do not have to make the copy of that. It means it is asked you have to do it inline. So I'll be trying to approaching this solution inline, and let's see how it works. So move zeros, okay, because I'm not taking any data structure. It said you have to do it inline in the same array. You have to do some operation. Of course, we will talk about that brute force a little bit, just to make sure that our brain captures it, or get the technique right. Okay, so at last, what we can do is s out. And since we have a primitive array, so we must have to use, because primitive array, it's like not very straightforward to string to print values. Yeah, so this is how you can print the value of in one line, uh, arrays to string nums. Yeah, so this is the problem. So I think problem is very clear. Maintain order of non-zero elements, and zero should come in the last. Uh, so yeah, let's discuss about this particular thing in a very expensive. So of course, when we create an array, what we can do, we can quickly create a new array of the same length as the input array in a brute force approach. Okay. Again, as I always point or highlight this thing, that whenever you are in front of the interviewer, you can just take 1 or 2 minutes of time just to discuss the brute force solution, and then also explain them that you are going to choose optimized version because of the XYZ reason, right? So over here, my brain says it is an array, and I can quickly create a new array of same length as an input array. Okay, and this is this size. Traverse the input array, copying all non-zero elements into the new array. Okay, so for example, all non-zero, and once all non-zero elements are added, then we are done. We just need to fill all the remaining elements with zero, and that's it. And then return the final copy of the new array back to the wherever it is required. So that is simple and plain and straightforward solution. Uh, Time complexity of O of n, space complexity O of n. But as you know that the statement already said to you, like, you have to do it in place. You do not use more any memory. It is using extra memory in your brute force approach, because you're taking a new array. Uh okay. Now coming to the part what and how we can, do this in terms of using without using any extra space. Uh, so there is something called, we have to think, okay, how can we avoid any space while maintaining the array order. So what we can do here, we can create a variable, let's say last non-zero index, to track the index where the next non-zero element should be placed, where the next non-zero elements, so 1, 3 and 12. So we can create a variable. Okay, we can name it little last non-zero index, something like that. And what this variable will do, it will always keep track of the index where you have to place next non-zero element, and then we traverse the array in a normal way. So if the element is non-zero, right, we move it to the last non-zero index, because last non-zero index will again always start with 0. Okay. So if the element is non-zero, we move it to that particular thing, and then increment that last non-zero index, let's say +1. And then again the element come, if it is non-zero, again moving it to, because last non-index 0 index will be moved to 2. But it doesn't matter, wherever you found, you just use that index to place the non-zero element. After all elements are checked, we are sure that all non-zero elements are moved forward, because we took this one variable last non-zero index tracker. After placing all non-zero elements, iterate the non-zero index. So let's say the final value is, in this case, 1 will be stored at 0, 3 will be stored at 1 position, but last non-zero index will be 2, and then when it counted 12, then it will be 3. So that variable will be total 3 uh, in its value. So after that, what we are left, we have to just go after 3 up to the length of the total size of the array and fill all those values with 0. That's it, right? Let me code it, and then you will explain. I'll explain one more time how exactly and what exactly I'm trying to achieve here. So as I said, let me create quickly last non-zero index. Okay, this is a trick. And then I say move non-zero um, elements forward, right? So we definitely have to iterate. So um, for I, because I'm tagging I, and this is would be nums dot length. All right. If nums of I, okay, I is not equals to 0, it is a non-zero value. If that is the case, we have to move it forward, right? But where, which location? Nums last zero index. Okay. And then it will be nums of I. Fair enough. We can do it like plus plus here just after that, because, or we can do it next line. So after this, our last non-zero index will be moved to 1. Next element comes in this array, and then it will be, and then what is left? We just need fill remaining positions with 0. All right. So I have this loop again, but this time I will start from where? I will start from last non-zero index, right? Because that will keep the track, and this will be nums dot length. And then what we have to do? We have to just say nums of I is equals to 0. And that's pretty much all in the solution. This is where the trick of having one variable which maintains or tracks the order of non-zero elements comes in picture, and it solves the problem in line. Time complexity of O of n, space complexity of time, complexity of O of n, all right, and space complexity O of 1, because we didn't took any space, right? So let me run this. Run 1 3 12 0 0. That's all good. And if we pass 0, let's check. Here we go. Run, and it's 0. Looks good. So let me quickly copy this and run it on LeetCode. Here we go. And run this solution. Yeah, it is accepted. I submit it. That's good. The solution is accepted. Now, thank you very much. I'll see you in another video.